Video notes 3.2, we're going to do naming those molecular compounds we've been drawing, more dot structures, and the end, which is electronegativity difference. All right, so you're going to be able to name and write formulas for compounds, differentiate between polar and nonpolar bonds, draw Lewis dot diagrams for atoms, the ions we're going to focus on today, and compounds, and apply the octet rule. So let's get busy. All right. Book connections. There's just 2 pages to read about polar and nonpolar bonds. Look at figure 8.3. Answer this question in your notes. Read section 9.3 and then do the checkpoint at the end, the bottom of page 269. Hey, you want bonus? Do bonus. All right. So let's review. Covalent compounds mean sharing electrons. So there's 2 nonmetals involved. Okay. And then we call it directional covalent bonding because it's in one direction, towards between 2 atoms. The electrons are stuck there. Oh, are those bunnies, Sharon? All right, here's what you got to know. That when atoms bond and share electrons, hydrogen's goal is to get 2. Boron and aluminum are done with 6. Phosphorus, sulfur, xenon, bromine, and iodine can get 10 to 12 around them when they're sharing, okay? Otherwise, we're doing an octet. Oh, look, it's NH3. What's the dot structure going to look like? Like this. And so nitrogen is 2, 4, 6, 8. Nitrogen's happy with 8. Hydrogen's happy with 2. So this is a good dot structure. You might be wondering to see if you have a good dot structure. Well, here's what you do to check. Count the total valence electrons. So count how many come in using the periodic table and make sure when you're done, that's how many you see. Make sure to give octets for nitrogen, oxygen, fluorine, chlorine, carbon. Those are all in row 2 on the periodic table. Okay, so row 1 is hydrogen and helium. All of these guys are in row 2. They usually have 8. Make sure hydrogen only gets 2. That's the periodic table. And then boron over here and aluminum right under it only needs 6 to be happy. Now, you could get more for sulfur, phosphorus, xenon, bromine, and iodine, but that's maybe. So, that's what you look for. Count the total valence electrons. Make sure you have octets, except for the exceptions. And then you might need to multiple bond, but only if you run out of electrons. Okay, so let's do a little more practice with ions this time. Ions have charge. Okay, so if you have single ions, like this is a single atom with a charge, so that's a single ion. Fluorine has 7 valence electrons that come in when it makes a dot structure. Now, this means it has an extra electron, 1 extra negative. So, now it has 8 valence electrons because the 7 it brought in plus the 1 more. So it's 1, 2, 4, 5, 6, 7, 8. Now, since it's an ion and has an extra electron, we put brackets around it and put the negative sign on the outside because it's got an extra electron. S negative 2. Sulfur brings in 6 valence electrons from the periodic table. Now it has 2 more because negative 2 means 2 extra negatives, which are electrons. So sulfur, 1, 2, I'll go around the other way just so you can see what's going on. Sulfur, 1, 2, 3, 4, 5, 6. 2 extra electrons. And then you put a negative 2 on the outside because it's got 2 extra electrons. So now, magnesium atom. So magnesium atom, period 2. I said period 2, group 2, 2 valence electrons. That's fine. I could put it top, bottom. I could put it side to side. As long as there's only 2 unpaired. All right. Magnesium plus 2 ion means that this loses those 2. So magnesium ion will look like this. Mg plus 2. It lost its 2 electrons and the charge goes outside the brackets. Polyatomic ions. Poly means many atoms in an ion, so many atoms with a charge. Count the total plus extra or minus the losers. Okay. Oh wait, this is an extra. So oxygen brings in 6 valence electrons, hydrogen brings in 1, so we have 7 plus an extra 1 equals 8 valence electrons. So you put the atoms, make a bond, 2, all right? So hydrogen's happy, 4, 6, 8. 8 around oxygen, 2 around hydrogen, and then you put the brackets around negative on the outside because it's an ion. Okay, poly, many atoms with a charge, polyatomic ion. Okay, remember negative means add more, positive means take away some. All right, so what do we do with this END stuff? Electronegativity difference, the end. Okay, electronegativity difference. 2 atoms have no difference in electronegativity. They're going to share electrons equally, and that makes a nonpolar bond. Share equally, no poles or differences created. Okay, so end, subtract, electronegativity difference. Negativity difference means subtract the two atoms in the bond. If their difference is very small, they're going to share the electrons equally. Some difference is going to make what we call a polar bond. Polar bond, non-polar bond. Okay, so they're going to share electrons, but the higher atom gets more of the shared pair. Poles are created. So then if the electronegativity difference is small, but still, like this is very small, this is kind of medium, then they're going to share electrons but not equally. That's called a polar bond. If there's a huge difference between the atoms, 2.0 or greater, there's going to be a transfer of electrons from low electronegativity to high electronegativity. So the end is the electronegativity difference. What's the end? What's the diff? Okay, so let's practice. Between N and O, 3 and 3.5. So here's 3, 3.5. What's the diff? 0.5. This is a polar covalent bond. Between fluorine and fluorine, 4 and 4 is 0. 4 minus 4 is 0. This is a non-polar covalent bond. Lead and fluorine. Lead 1.8, fluorine 4.0. 4.0, 1.8, 3.8, 2.8, 2.8. What's the diff? 2.8. That's going to be ionic because that's above 2. Okay, C and H is 3, 2.5, and 2.1. What's the diff? 0.4. So this is a nonpolar covalent bond. So what does that really mean? Okay, nonpolar covalent bonds. Happens between two nonmetals. It's called the nonpolar covalent bond. Electrons are shared evenly or equally. The electronegativity difference is between 0.4 and 0. Okay, mostly diatomic elements like N2 or H2 are going to make these kind of bonds. What about Cl2, nonpolar covalent bond? What about Br2? All of our diatomics. Nafkulbri, huh? All right, iodine. All right, fluorine. There's all 7 of them. They're going to have nonpolar covalent bonds because they're going to have equal sharing of electrons. A CH bond is going to be nonpolar because its difference is 0.4. What does that mean? That means the two things involved equally get the electron density. Neither of them gets more of the electron density. No poles, nonpolar. No poles, nonpolar. Because it's equal. No opposites, nonpolar. Okay, what is a polar covalent bond? So if I was sharing the strawberry with this little character, I would get more of the electrons, or I would get more of the strawberry because I'm a little bit bigger. So that's what a polar covalent bond is, sharing unevenly. Okay, the atom with the higher electronegativity is going to have a slight negative charge. The other atom will have a slight positive charge. A bond or molecule with an uneven distribution creates what we call a dipole. Uneven sharing, it's a dipole, it's polar. This is a delta. It's a Greek lowercase delta. You could have a delta negative and a delta positive. All right. So there's going to be a side of a bond that's kind of negative, a side of the bond that's kind of positive. We also use an arrow called a dipole arrow to show the same thing. This points to the kind of negative. That's on the kind of positive side. So what do I mean? Oh, looky, poly bear. Nitrogen has an electronegativity of 3.5. Oxygen's 2.5. What's the diff? I think I did that wrong. I think nitrogen's 3 and oxygen's 2.0. 3 and 3.0. Okay, 3 and 3.0. Let me change this. 3.0. Oh, I just messed it up again. What is it? Oxygen's 3.5. Alright, so 3.5 and 3.0. What's the diff? 0.5. So here's the NO bond. I'm just drawing it again to write on it. So the arrow would point to that side. Alright, you could put the arrow on it. That's called a dipole arrow. This points to the kind of negative. Or you could put the partial charges. Or you do both. Alright. So this side of the bond is the bigger side, more electronegativity, gets a little more of the electrons around it. This side gets less of the electrons around it, but they're still sharing electrons. Dipole means polar, polar bond, like a polar bear at the North Pole, if you want to make sure you know that polar bear means a pole. You draw an arrow or the partial charges to be able to do that. Okay, what do we call these things we've been working with? Two nonmetals. You use prefixes to please memorize what the prefixes mean. Mono is 1, di is 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. We're going to use these prefixes to say how many of each kind of atom there are. The ending of the second word is "ide." Second word. All right, so let's practice it. Second word is "ide." All right, so SF6. Name of the first one, sulfur. Now you might be saying we need a prefix, right? How many sulfurs? 1. The only time you don't need a prefix is no mono on the first. So we don't have to write monosulfur, but we need a prefix for fluorine. There's 6, so it's hexafluoride. Okay. All right. Phosphorus. Do we need a mono? No mono on the first. Phosphorus. Phosphorus. How many? 5. Pentachloride. Pentachloride. All right. Oh, look, it's xenon in a bond. That's crazy. Okay, how many? Di-xenon. How many bromides? 8 octabromide. All right. Keep going. Look, all of these end in "ide." Second word ends in "ide." H2O, 2 hydrogens, dihydrogen. Dihydrogen, 1 oxygen. You always need a prefix on the second. Monoxide. All right. And then remember to end in IDE, no double O's. Okay. What if I see the name trinitrogen monosulfide? Then I would say nitrogen. There's 3 of them. 3 monosulfide, N3S. Hexasulfur, 6 X's. Dichloride, Cl2. Decanitrogen, N10 monoxide, N10O. So prefixes tell you how many. No mono on the first, no double O's, and end in IDE. Moving on to review. Okay, this is the bear song because we have polar bears. Covalent bonds share electrons unevenly, polar bear, and then evenly, no poles, no bear, non-polar. Oh, look, uneven polar. Hey bear, do you live at a pole? Evenly, no pole. Polar bonds, point the arrow towards the hog, and the hog gets a partial negative. Dipole arrow, partial negative, partial positive, right? Nonpolar bonds, no arrow, no partials. You can tell properties, electronegativity, and types of atoms, okay? Tell us what kind of bonding. So, make sure you do these things, all right? Read section 9.3, do checkpoint on page 269. Hey, want bonus? Do bonus, all right? So if you see a bear, take him out to lunch with you, all right? Yay, bear, the bear song. Anyway, peace out, all right? Make sure you can do all these things. For real, peace out.